So this is to demonstrate the actual movement of it. A couple other things I forgot to mention. The speed that this closes and opens is relatively slow. So this is its ability to move. And now if you notice, it's pushing right at the center of gravity for that door, which means that it's a much better and a more efficient stroke than the handle that is pulling on the bottom. Because normally when that fails and strips out, you end up bending the door up and the gear turns, and that's a good thing. You won't have that on this. At the worst case, this is going to amp out if it somehow reached a limit without being able to shut. So if something was blocking the door and it couldn't shut all the way, you get a high amp, you could limit it out, and it actually probably has internal circuit protection. Now, the speed this door goes is only to be able to get to this higher horsepower, so you could actually get any speed you want. We could make this door cycle open and close in the matter of 5 seconds or something like that if we really wanted to. But it doesn't have to for most purposes, and it's probably cheaper if we can keep it at a low torque and low speed. But anything can be done with linear actuators if you get the speed right. So this is the door opening. Now another good use for this, these linear actuators can be bought with internal feedback. So the internal feedback will tell you the actual position of this at any given time. So rather than having the situation where you don't know if the door is 90% open or 10% open, you could read it actively, and if you wanted, you could meter the material coming through here at whatever rate you want. So if you were doing blends or whatever, or if you just wanted to have a certainty that this gate is either open or shut, that would give it back to you, and it really isn't that expensive to put the feedback portion in there. All right, so that's what you're looking at here.